This is section 2.2, Basic Differentiation Rules and Rates of Change. In the last lesson, we learned how to take the derivative of a function using the definition of a derivative with a limit. And today we're going to learn some short differentiation rules that are going to make it a lot easier so we don't have to do limits every single time. So the first rule we're going to talk about is the constant rule. So the derivative of any constant function is 0. So for example, if we had f of x equals 5, f prime of x would equal 0. So the derivative of any constant function is 0. We have the power rule. So the derivative of x to the n is n times x to the n minus 1. So for example, if we had f of x equals, let's go x to the 6th, f prime of x, we bring that 6 down in front, so 6x, and then we take away 1 from the exponent, so it becomes 5. So the derivative of x to the 6th is 6x to the 5th. The constant multiple rule says that if you have a constant times a function, the derivative is the constant times the derivative. So if we combine the constant multiple rule and the power rule, let's say we have a function f of x equals, let's go 4 x cubed. What that's saying is we can take that 3 down times that 4 to get 12, and then we bring that 3 down to 2. So the derivative of 4x cubed is 12x squared. Notice that's the same as if we just did 4 times the derivative of x cubed by itself, which would be 3x squared. And then the sum and difference rule, if you have things being added or subtracted together, the derivative is the derivatives added or subtracted. So for example, if we had f prime of x equals, let's do 3x to the 9th plus 4. Oh, that's just the derivative, so that shouldn't have our prime. So if we had f of x equals 3x to the 9th plus 4, f prime of x, we just take the derivative of the parts. So this becomes 27x to the 8th, and the derivative of 4 is 0, so we just don't even need it. So let's find some more derivatives. So the first one, f of x equals 7, that's our constant rule, so f prime of x just equals 0. Next one, we have the constant multiple rule and the power rule. So f prime of x, we take that 3 multiplied down by the 5 to get 15, and then decrease the exponent by 1, so we get 15x squared. The next one's a little bit trickier, but it's just as easy, you just have to know how to write it. So remember that the square root of x, I'm going to write it over here, 2 square roots of x. Remember, the square root of x is the same thing as x to the 1/2, so I'm going to rewrite that as 2x to the 1/2. Now this looks very similar to what we just did. So f prime of x, bring that 1/2 down, multiply by 2 to get 1, and then we have x to the negative 1/2 when we subtract 1. Notice that if we do that, that becomes 1 over x to the 1/2, or 1 over the square root of x. Same thing with the next one. We have f of x equals 1 over x to the 4th. I'm going to rewrite that as x to the negative 4th, because then our derivative looks pretty easy. So f prime of x, bring the negative 4 down in front, decrease by 1, so now it's negative 5. And we can rewrite that to be negative 4 over x to the 5th. All right, f of x equals x cubed minus 4x plus 5. So we have a bunch of things being added or subtracted, so our derivative is the derivatives added or subtracted. So here we have f prime of x. So the derivative of x cubed is 3x squared. the derivative of 4x is just 4, and the derivative of 5 is 0, so I can leave that off. And lastly, finding this derivative, I'm going to rewrite this because I don't like that negative x to the 4th over 2. I'm going to rewrite that as negative 1/2 x to the 4th. I just like things to be a little bit more in the way that we know them better, so we can use our derivative rules a little bit easier. So the derivative, 4 times negative 1/2 is negative 2, goes down to a 3, plus, multiply that 3 down so we get 9x squared, and then we just have minus 2. So notice that this is a 1 right here, so when we multiply it down we just get minus 2, and then x to the 0, but remember x to the 0 is always equal to 1. So that's how we just get that negative 2. A couple more rules we have here, derivative of sine and cosine. So the derivative of sine of x is cosine of x, and the derivative of cosine of x is negative sine of x. So let's try to apply that. So the derivative of 2 sine of x, f prime of x, we're going to have the constant multiple, so we just have 2, and the derivative of sine is cosine. All right, that next one, remember that's like 1/2 sine of x. So our derivative, constant multiple is that 1/2, sine goes to cosine, and so there we are. And last example we have for this one, f prime of x, the derivative of x, remember that's like x to the 1st, the 1 goes down, becomes 1, and then x to the 0, which is just 1, so we have 1, and the derivative of cosine is negative sine. All right. So remember, derivative gives you slope, and slope is another name for rate of change. So this leads us to a major application. If you are given a position function, the derivative gives you velocity. Okay, and if you're given velocity, the derivative actually gives you acceleration. So this is why physics likes to use calculus a lot, because it's easier to calculate speeds and such. So at time t equals 0, a diver jumps from a platform diving board that is 32 feet above water. The position of the diver is given by s of t equals negative 16t squared plus 16t plus 32, where that should be, or where s is measured in feet, so the height is in feet, and t, the time, is measured in seconds. So when does the diver hit the water? Well, we know the diver hits the water when the height is 0. So let's first find out where the height is 0. So 0 equals negative 16t squared plus 16t plus 32. I'm going to solve by factoring, so I know I can factor out a negative 16 first. So we get t squared minus t minus 2. If we divide both sides by negative 16, that one just goes away, so we don't have to worry about it. And then let's factor this t squared minus t minus 2. So we get t minus 2, t plus 1. So this one tells us that t is equal to 2, this one tells us that t is equal to negative 1. But remember, we don't like negative time, so that one's out. So t equals 2 for that first part. So after 2 seconds, the diver hits the water. Now to find the velocity at impact, we're going to find the derivative, and then we're going to plug in 2. So let's start by finding s prime of t. So we bring this 2 down times the negative 16, so we have negative 32t plus 16, and then that 32 goes away. So s prime of 2 equals negative 32 times 2 plus 16. So we get negative 64 plus 16 equals negative 48. So, since it's in feet and seconds, so it's negative 48 feet per second. The negative just tells us that the diver is moving down and not up. And then the 48 tells us actually how fast it's going.